Hello everyone, today I want to give a short introduction for magnetoelectric multiferroics. So before talk about our main topic, firstly I want to talk about ferroelectricity. The first question is, what is ferroelectricity? For a ferroelectric material, there will be a spontaneous polarization like this. And if we apply an external electric field to this material, and the direction of this electric polarization can be switched. If one material could have this kind of property, we will say it has ferroelectricity. Next, let's talk about ferromagnetism. For a ferromagnetic material, there are unpaired electron spins, and the electron spins will line up with each other parallelly inside an area. And we call this kind of region a magnetic domain. However, in practice, there are a lot of domains for realistic materials. And for different domains, it will have different orientation. So the overall material usually appears to be unmagnetized. And similarly with what we did for the ferroelectricity with external field. For this case, we can also use external magnetic field to change the direction of the electron spin. And finally, for different domains, it will line up with each other parallelly. We have just discussed about the definition of ferroelectricity and ferromagnetism. And here are some example materials. And for traditional bulk material, perovskite are good candidates for ferroelectricity. And for ferromagnetism, the ionic materials are good examples. And the van der Waals materials can go to two-dimensional, and there are also 2D candidates for ferroelectricity and 2D candidate for ferromagnetism. We have just discussed about ferroelectricity and ferromagnetism separately. And if one material can have these two properties simultaneously, we will say it is magnetoelectric multiferroics. If ferroelectricity can couple with the ferromagnetism, and we call this kind of coupling effect magnetoelectric effect. That is to say, an external field can not only have an influence of the electric polarization, it can also change the magnetism. And vice versa for the magnetic field. The magnetic field can not only change the magnetism, but also can control the electric polarization. This kind of property could have a lot of applications. One of the most interesting applications is magnetic field sensing. There are examples of the experiment which can make multiferroic materials into the sensors, and the sensors can sense the variation of the magnetic field. The key point is still magnetoelectric coupling, and here is an easy understanding example. If there is a multiferroic material, and due to ferroelectricity, there will be a spontaneous electric polarization. And if we apply an external magnetic field to this material, and the magnetic field is changing, there will be a correspondence variation of the polarization due to the magnetoelectric coupling. And this kind of change of the polarization can be easily resolved by many methods, like voltage output. This property makes multiferroic material a good candidate for magnetic field sensing. Another application is memory storage. If we put a ferroelectric material and another ferromagnetic material together, it will form a multiferroic heterostructure. And this kind of heterostructure could have a lot of applications. One of the applications is the memory storage to save binary information. And the key point is the still magnetoelectric coupling. Here is another easy understanding example. Here is a heterostructure, which is multiferroic heterostructure. And for the magnetic layer, it can be divided into two parts. For the first part, the direction of spin is fixed and will be never changed. And for the second layer, the direction of spin is free, and it can couple with the ferroelectric layer, and the magnetization can be changed. When there is no external perturbation, the total magnetic layer will stay at the first state. And if we apply an external electric field to the ferroelectric layer, it will change the polarization and the ferroelectric layer will couple with this ferromagnetic layer. There will be a variation of the magnetization. So the total magnetic layer will be switched into another state. So the two different states will have two different electric resistance where the binary information can be saved. Here we just discussed about the magnetic field sensor, memory storage. There are many other applications like an antenna, energy harvest, phase shifter, tunable inductor, and we will talk more about the magnetoelectric multiferroics in the future.